so for our first number property, we have the commutative property. Now, can somebody tell me what the word commute means? Like, I commute every day to work. What does that mean, Brittany? Exactly. It means I'm driving myself from home to work every day, right?
Yes.
So I'm commuting to work. I'm moving myself from home to work. So the commutative property means that we can move all the numbers around when we add and multiply, and we still get the same answer. So we have two commutative properties. We have commutative property of addition, which means if I add two numbers, a 3 plus 6, I can flip those around and get 6 plus 3, and I still get the same answer. Is that correct?
Yes.
Yeah. So when we are adding, the order that we put the numbers in doesn't matter. We still get the same answer. Now the same thing is also true for multiplication. If I am multiplying two numbers, the order that I multiply those numbers doesn't matter. I could multiply 2 times 4, which gives me 8. And 4 times 2 also gives me 8. So the order in multiplication does not matter. Now, what about subtraction and division? Does order matter there?
Yes.
Yes. Let's do an example, okay? So let's say I want to check subtraction. Okay, I'm going to do 4 minus 2, and then let's try 2 minus 4. What does 4 minus 2 give me? 2. What does 2 minus 4 give me?
Negative.
Good, negative 2. Are those the same?
No.
No. So subtraction order does matter. What about division? Does order matter there?
Yes.
Yeah, let's try it. Okay, division. Let's do 6 divided by 3. Is that the same as 3 divided by 6? What's 6 divided by 3? 2. And what's 3 divided by 6? No, it is not. Okay, let's reduce this. How many times 3 go into 3? 1. How many times does 3 go into 6?
1.
Twice. Okay, so what is 3 divided by 6? 1/2. Is 2 and 1/2 the same?
No.
No. So order also matters in division. Does that make sense?
Yes.
Okay. Wow, guys. Alright, so what about, next one is associative property. If I say that Marissa and I associate with each other, what does that mean? Rolando? It means we talk to each other, it means we hang out with each other, right? So associative property has to do with the grouping of numbers and variables. Who's hanging out with who? Okay? So that means that we are working with parentheses. Okay? So if I have a problem, 2 plus 3 plus 4, if I have 2 plus 3 in parentheses and plus 4 on the outside, I'm still going to get the same answer as if I put 3 plus 4 in parentheses and keep 2 on the outside. Okay, let's try it. According to order of operations on this left-hand side, what am I going to do first? The parentheses, 2 plus 3, which gives me what? 5. And then I have plus 4 on the outside, right? Equals. On the right-hand side, what part am I going to do first? The parentheses. So we have 2 plus what? 7. Now let's think about it. 5 plus 4 gives me what? 9. 2 plus 7 gives me 9. Are they the same?
Yes.
Yeah. So it does. In addition, it does not matter where we put the parentheses or who's associating with each other. Same thing is true for multiplication. Okay? I could put 5 times 2 in parentheses and multiply by 6 on the outside. Or I could put 2 on the outside and 5 times 6 inside the parentheses. And I still get the same answer. So according to order of operations on the left-hand side, what am I going to do first? Parentheses. So 2 times 5 gives me 10 times 6. And on the right-hand side, 2 and 5 times 6 gives me 30. So what's 10 times 6? 60. And what's 2 times 30? 60. Are they the same? Yes. Do you think associative property works for subtraction or division? No, it does not. It does not. Okay? So we only are working with addition and multiplication here. Any questions so far? Yeah. Okay, next we have the new property we just learned, distributive property. Remember, distributive property says that we can multiply every number inside the parentheses by the number on the outside of the parentheses. So in our example, we should know this, right? 2 times x plus y, we distribute the 2 into the parentheses. 2 times x gives me 2x, and 2 times y, 2y. Okay, we already know that one. We learned it on Monday. We also have 2 identity properties. Now, an identity means are numbers that when we add, if we add the identity, we still get the same number we started with. If we multiply by the identity, we still get the same number we started with. So what do you think the identity for addition is? What number can we add to any number and still get the same original number? What number do we add that doesn't change the answer? 0, right? 5 plus 0 gives me 5 still. It doesn't change. So 0 is called the additive identity. Okay, what number can we multiply that won't change our answer? 1. So 1 is the multiplicative identity. Multiplicative. Okay, then we have what's called the zero product property, which is really easy. We've been doing it since we learned multiplication. 0 times anything always gives an answer of 0. That's the zero product property. All right. Last one, we have what are called inverses. Now the additive inverse has to do with, what do you think? Addition. Okay, and we've actually already learned this when we were learning how to solve equations. Okay, the additive inverse is also called the opposite of a number. That means when we add those two numbers together, we get 0. So to take the opposite of a number, what do? We change the what? The sign. Good. So what would be the opposite of 3? Negative 3. What would be the opposite of negative 10? Positive 10. Why? Let's say 4. If I have 4, what's the opposite of that? Negative 4. And what is positive 4 plus negative 4? 0. 0 is what? 0 is the identity for addition, right? Because if we add 0 to a number, we still get the same number. So what we are trying to do with inverses is we are trying to reach the identity. So the opposite gives us the additive inverse, or the additive identity. Okay? So in multiplication, if we are trying to get to the identity, what do you think the multiplicative inverse is? We've already done this. It's called the what? The reciprocal. How do I find the reciprocal? If I have a number, say 5, that's the same as 5 over 1. And so what would the reciprocal be? Good, 1 over 5. What would be the reciprocal of negative 100?
Positive 100.
Okay, how do we find the reciprocal?
different number.
We flip it. How do I find the opposite? We change the sign. So what would be the reciprocal of negative 100? Negative 1 over 100. The sign does not change for reciprocal. What is the opposite of negative 100? Positive 100. Okay, why does it work? Because we have 2. 2 is the same as 2 over 1. So what's the reciprocal of that? 1 over 2. And what's 2 times 1 over 2? 1. Okay, so that is called the multiplicative inverse, or the reciprocal. So, example 1, all we want to do is identify the property here. So for example 1, here's what we have. 10 plus 3 equals 3 plus 10. Look in your spiral book. What property is that? It's commutative property. Good, because we're changing the order. It's commutative property of what? What are we doing? Are we adding or multiplying?
Adding.
Adding. So it would be commutative property of addition. Yes. You need to specify if it is addition or multiplication. Yeah, everyone is writing right now. That's all you need to do. So example 2. 7 plus 4 in parentheses plus 6 equals 7 plus in parentheses 4 plus 6. Now what has changed here? Has the order of the numbers changed? No, but the way they are grouped has changed. So what property is that? Good. It's associative. It's associative property of what? Good. Addition. Okay. This time we have 1 over y times y equals 1. What is this one? Look in your spiral book. What is this one? Rolando, what do you think it is?
Inverse.
Yeah, it's the inverse for what? What are we doing? Are we adding or multiplying? Good, multiplying. So we call that multiplicative inverse. Multiplicative inverse. Okay? So we are multiplying two numbers and they equal 1. What's the multiplicative inverse also called? Starts with an R? Reciprocal. Good. Okay? Example 4. Moving right along. 8 times 2 in parentheses times 4 equals 8 times in parentheses 2 times 4. Did the order change at all? No. Alright, did the order change here, guys?
Yeah.
8, 2, 4, 8, 2, 4. Order did not change. But the grouping did, so it's what, Brianna? Associative property of what?
Multiplication.
Yes. So associative prop of, I'm not going to write multiplication the whole way. Okay, t times 1 equals t. Which one is this? Danielle, which one is this?
Identity property for multiplication.
Yes, it's identity for multiplication. Good job. Okay, so let's say ID mult. Okay? Identity property of multiplication.